Automobiles are noisy. From compressor noises to motor vibrations, these sounds cause problems, such as things braking on the vehicle or discomfort to the driver. With the emergence of electric vehicles, new problems arise, specifically in vibration issues and the noise around vibrating car parts. Once masked by a combustion engine, engineers must now problem-solve new vibrations found in quiet electric vehicles. Historically, these problems were addressed during modal analysis and FEA in mechanical design. Engineers approached the challenge through a hammer test to determine the natural frequency of the product. After repeated shape changes, prototyping and testing, the outcome is determined. The traditional process requires extensive time and resources, hindering company competitiveness in the market. In an increasingly electrified world, controlling vibrations and unpleasant sounds is important for electric vehicle manufacturers. NewtonSuite AVES is a design support tool that improves prediction accuracy and provides efficient evaluation of vibration characteristics, including assemblies. Many assembly vibrations are affected by contact surface boundaries, which are often difficult to evaluate and obtain accurately. The software provides the features necessary to evaluate such issues. Engineers can save time and costs using AVES to determine design limitations before the prototype is created and tested. NewtonSuite AVES is the world's first software to introduce contact surface stiffness into a finite element model and can efficiently predict the vibration of a motor and an electric compressor.